Okay, we have a potential divider here. So in order to find out what is the voltage across R2, right, we have to use the formula. It will be R2 over R1 plus R2 multiplied by the input voltage of 6 volt. So to find out which pair of resistor will give us an output voltage of 1 volt, basically we can just calculate the voltage across R2. So what we can do here, we can add another column. Okay, so for A, V it will be equal to 5 over 6 multiplied by 6, we get 5 volts. This is not the answer. For B, it will be 6 over 7 multiplied by 6. This will give us about 5.14 volts. Then for C, it will be 1 over 6 multiplied by 6. This is going to give us 1 volt. So C is the answer. But we just calculate for D. V is equal to 1 over 7 multiplied by 6. This is going to give us about 0.86 volt. Okay, so it's very obvious that the answer is C. We are given the voltage and the power across a lamp. So we are supposed to find out what is the resistance. We can use the formula P is equal to V square over R. So R will be equal to V square divided by P. We will get 250 square divided by 100. So we will get the answer as 625 ohm, which is option D. Okay, to find the cost of electricity, right, we have to find out what is the total energy used in kilowatt hour. So we are now looking at using the electric cooker during one day, and the electric cooker consists of a hot plate that is switched on for 1 hour and the oven switched on for 3 hours. So the total energy in terms of kilowatt hour, it will be equal to power times time. Power must be in terms of kilowatt, and the time has to be in terms of hour. So it will be, okay, for the hot plate, it will be 1500 watt. So we have to change it to kilowatt. So it will be 1.5 kilowatt multiplied by the time that is being switched on, which is 1 hour. Okay, this is for the hot plate. Then we have the oven. Oven power rating is 2000 watt, so that makes it 2 kilowatt, and it's being switched on for 3 hours. So the total kilowatt hour used, it will be 7.5 kilowatt hour, and 1 kilowatt hour costs 24 cents. So 7.5 kilowatt hour, it will cost you 7.5 multiplied by 24 cents, and that will give you 180 cents. So the answer should be C. Okay, in this question we are asked what is the most effective method of demagnetizing a permanent magnet. Okay, the most effective method will be using the electrical method, and we have to use an AC supply. So A and B, they are wrong. Okay, and after we connect an AC supply to a solenoid in which we slot in the magnet, we have to slowly pull it out so as to randomize the atomic magnets in the permanent magnet. So the answer is D. Okay, we have a current that is going upwards in a vertical wire X, Y. So this will produce a magnetic field in the region around XY. So which one shows the correct pattern of magnetic field lines produced? Okay, so in this case, right, we can use the right hand grid rule. The thumb indicating the current direction, and then the finger, it will curl around the thumb, which is the wire, in a circular motion. So the circular plane, it should be perpendicular to the wire. So the answer should be A.